Hi. No.
So let's get started. Letting everyone in. All right.
Hello, Professor.
Yeah, go ahead, please.
I had a question about the homework.
Yes. Are you still there?
Yeah.
What's your question?
It was the question about the phone number lookup with the two parallel arrays.
Oh, okay.
Yeah, I didn't really know how to start that.
You don't
Like I
know?
just made the two lists.
Okay, and you don't know how to start it?
Yeah, I just made the two lists, and then I don't know what's the next step.
Let's read through that one then. What is this array?
Yeah, it's the two parallel arrays. It's the phone number lookup problem.
What number is it?
Number 7.
7. All right, so let's go through that. Okay, I'm going to share this. All right, so you guys should be seeing the problem now. It says phone number lookup, design a program that has two parallel arrays, a string array named people that is initialized with the names of 7 of your friends, and a string array named phone numbers that is initialized with your friends' phone numbers. The program should allow the user to enter a person's name or a partner's name. It should then search for the person in the people array. If the person is found, it should get that person's phone number from the phone numbers array and display it. If the person is not found, the people array, the program should display a message indicating so. Okay. All right, sounds like a good problem. Let's go through it then. All right, so I'm going to share. Oh, I need to share the. All right. I'm currently sharing the IPython notebook. You should. Microphones, okay. So we need to create a list. So, remember an array is a list here. So people, right? And it's going to have 7 names. Then phones.
You doing that? Yes.
I'm going to mute your microphones, guys. All right. So I'm going to create a phones list and a list of people, right? So let's say, John, Robert, Alice, Mary. Oops. How many is that? 4. Benjamin. got 1, 2, 3, 4, 5. Jennifer. Joseph. Oops. Okay, so I got 7 in here. 1, 2, 3, 4, 5, 6, 7. Now I need 7 phone numbers. So say 555 2, 3, 4, 5 4, 6, 7 or whatever. 1, 2. These are also strings. Then I'm gonna do 1, 2, 3. Okay, that's 3. That's 4. That's 5. 3, 4, 5. 2 more. And 1 more. So that's where you were, right? You had 1, 2, 4, 5, 6, 7 names. 1, 2, 3, 4, 5, 6, 7 phone numbers. All right, so actually, Python is really great for this. It makes it really easy. All you have to do is you're searching for a name, right? So the first thing is you need name to search. All right, and we're going to initialize that to blank, and then we're going to say print enter name search. And then we're going to have name to search, and it takes on input, which will be a string. All right, and that's it. Then now you want to do the search, right? You have the name. So really, you're going to search in people. And what you can say is so there's a couple of ways of doing this. The simplest way, most intuitive, I would say probably, is for I in range. Right? And then what's the range? Remember, when you have lists, you want to do the length of it. And so in this case, I'm going to do people. All right. And then now 1, 2, 3, 4. So I have the I for each iteration. And now I can do if name to search, search in. And this in allows you to take, a substring, like 3 letters, and look for them inside another bigger string. So I can say if name to search, oh yeah, I already said that. In people I, colon. What does that mean? If it's in there, you found it, right? You found the match. So now what you need is that index, and you want to print out the name. Right? So you want to do, I'm trying to think what's a better way of doing this. I think that should work. let's just try it. So print, so what are you going to print now? The phone number, the corresponding phone number. So that should be phones given that I, that index position. Just like, you know, it's easier to read for me. All right, so then, you know, but it says, now the question is, if you didn't find it, right? If you get to the end and you didn't find it, then what do you do? So here we have to think about that. So we need to have some kind of control probably. So I don't actually like to do what I'm gonna do, but I think this is the easiest one to understand. I mean, there are more efficient ways of doing this. I'm just gonna create a found false Boolean. And instead of doing this, print here, I'm just going to say if in, I found it. Found, so I'm going to set found to true, right? And I'm going to say the index where I found it, I'm just going to use found index. And this is going to be -1. So actually, you know, I don't even need the found false because I could have just used a -1. But found true, let's say, and otherwise, oh, and I need to definitely the index. Found index, and I'm going to assign to it I. All right. And then now at the end, I just have another if statement and say if, you can either use found false or found index. Let's just use found. If found means actually, I'm going to get rid of that found because I don't really need it. It just doesn't look nice. If found underscore index equal -1, what does that mean? What does that mean?
It means that the name wasn't found.
Exactly, it was our phone, right? It wasn't found. However, else, it's not -1. It means you found something. And so then you can just print out the phone number. So here I'm going to do phones. And what's the value here? It's going to be found index. All right. So now let's try this. I think it worked out actually. I don't think it's a bad. I certainly didn't like that found true false thing, but I like this is okay. All right. So now I'm gonna run it. All right, and I'm just gonna say Ben. Right, Ben is, you know. Let's see if I find Ben. Okay, is that Ben's phone number? It is not.
Yeah, it is.
Is it?
Yeah.
1, 2, 3, 4, 5. 1, 2, 3. Oh yeah, you're right. They're just not aligned, right? Okay, good catch. Yeah, so it works, right? So that's Ben's phone number, and we didn't type the whole thing, so we met the conditions of the problem. I'm gonna try another one. All right, let's see. Bert, right? Let's say Bert. That's the nickname of your friend. Bert. Bert. Robert is the second one. So it's 5, 4, 3, 20. Yeah, there you go. All right. Does that answer your question?
Yeah, the only question I got now is
would you be able to show the output if you like don't put in one of the 7 names?
Just have to use a long key that's not gonna be in any. For instance, I can do.
Because when I put a name in that like doesn't that isn't in the list, it prints the name is not in list 7 times, or I can change it to phone not found. How would I get it to just print that once? Is that the like?
You do your code like mine, correct? You're just running your own code.
Yeah.
You're probably putting that print statement in the for loop itself. That's what it sounds like if you're getting 7 of those.
Okay. Yeah. That is.
And what I did is I had an index outside, and then when I leave the for loop, that's when I print just where I found it.
Okay.
Make sense?
Yeah.
Let's say Zelda, not there, phone not found. You see that?
Alrighty.
All right, great question. Any other question?
Yeah, can you go over the found index?
All right, so no other questions. It seems I'm going to close this out. All right, and today we are going to start a new topic. Work through the problems. That's the best thing, okay? Work through the problems. Make sure you're getting, that's what's so great about programming is that programming gives you that feedback immediately, right? Because you the code. All right, so as you can see in the slides, you should be seeing my slides now. We have 2 topics today. Input validation, which is pretty short, and we've actually done this quite a bit. So it's a short chapter. And then after that, we're going to start the very, very powerful topic of files. Right? So files are certainly very important. And we use that quite a bit when you program. All right, so begin then. All right, so we have here input validation. So input validation, such an important chapter, even though it doesn't seem so in your book, that you guys actually have a class for it called ITS 450. And basically, it translates into input validation. That's all it is, all semester. All right, so, but here it's a pretty short chapter, and it's really because we've already covered a lot of the principles of it, a lot of the programming techniques. This is just an application of the program. So the basic so this relates to how data flows into a program. So there's this saying, in programming, or in anything really, in computing, garbage in, garbage out. And what that means is if you don't watch what the inputs are, don't expect the program to give you good results, right? You have to validate. Your inputs to get, good outputs. In computing nowadays, in the age of cybersecurity, this is an issue that relates to security. And also in just writing good code is an issue that relates to quality. All right, so that means, if a user, we just did that, right? Just a second ago, we were taking inputs like names, etc. And you guys assume you would be entering names like you know, John, Mary, etc. But what if somebody entered a command in there that said delete, or you know, what was it? Format C dot dot, right? A command that you write in the in the command line in DOS and CMD on Windows to format the hard drive. Would this work? Probably not. Probably not, because this is not tied to the operating system. But what you should understand is if you have a computer and then you have the command line over here, right? And then you have some program over here which takes in inputs, and the input is format C dot dot, that input comes through here. It might stop there and not go further. But what an attacker would want to do is find a way to get to the command line. And if you don't have a, you know, if you just have one user with root privileges and everything like that, they could actually succeed, right? Or maybe they just want to view your data, right? Maybe they just use a dir, oops, you know, which is a command to list the directories, right? And maybe that's what they want. They just want to see what you have in there. They want to know which computer is the one that has the information they want. Okay, and so the point is that inputs can be very dangerous, okay? From a security point of view, but also from a quality point of view. Right, from the quality point of view, it would be that, you know, before in that previous problem, we were entering names, but what if people start entering, you know, John at email? That's not exactly a name, but people might make this mistake, right? And so you got to validate for that. That's what input validation is, that you have to check the inputs and basically say, okay, this is right, this is wrong, etc. Okay, usually that's done with something called the input validation loop. All right, so as you can imagine, before, so when I was entering that name for the lookup search, I could have had, before the main loop that was doing the search, I could have had another loop, and that loop was going to be used for the input validation. Okay. All right, so now what that also translates into a philosophy called defensive programming. And in defensive programming, what you have to do is you have to, you know, write code that protects your system from things like these. Okay. All right. So garbage in, garbage out. If a program reads bad data as input, it will produce bad data as output. Okay. So that, you know, I've said that, pretty straightforward. Program should be designed to accept only good data. And you as the programmer can define what that is. You are the creator of that program and you have full control. If you're being paid by someone to develop a program, then you're, you know, that the owner or the person paying you, right, for your consulting will, you know, will have specific goals that they want to meet. So in input validation, all input should be inspected before processing. If it's invalid, it should be rejected, and the user should be prompted to enter the correct data. That's why you're in a loop. It's like a loop. It's an infinite loop in a way that you don't get to leave until you enter the right input. All right, so here, let's look at this program. You know, this is a normal program for processing pay, right? So you have variables to hold the hours worked, the hourly pay rate, and the gross pay. So you have those there, hours, pay rate, gross pay. Then you get the number of hours worked to display a message, and they input the hours, right? Let's say that they work 400 hours. Okay, and then it says get the hourly pay rate, enter the hourly pay rate. You do that as well, whatever it is, you know, $20 an hour. And then you calculate the gross pay. So that's just hours times pay rate. So you can see that here, right? Hours times pay rate, right? And then finally, you maybe convert it to a specific format, you know, with $sign and everything, and you get 20 times 400, which I'm assuming that's 8,000. So you can see that there, all right? So that's all great and all. That's what you intended, but just because that's what you intended doesn't mean that that's what your users are going to do. Think about it. You know, the wide range of people that use computer systems, you know, I could read this and it says enter the pay rate, and I could just get confused, you know, about what they mean, or you know, I input hours, the number of hours worked per day, per week, per month, you know, all those things. So there's a lot of things that can happen. People can get confused. Input hours, people could write 8, you know, the word 8 instead of the number, you know. So a lot of problems can happen, right? And then there's the people that just want to crash the system and they just type whatever and see what happens. So you know, you want to validate for all of that. So for that, then we're going to use the input validation loop. We got the input validation loop here. It's commonly done with a loop that iterates as long as input is bad. So the logic containing an input validation loop is you get the input, right? So you have some kind of an input, then you check, you have to have some condition. For instance, is this a string? Is this an integer? Does this have an @ sign? Does this have this and that, right? You check for all of that. And that can vary quite a bit. You check a range, is this number? So for instance, somebody could enter 1 million hours, that they worked 1 million hours. Okay, usually no one's going to work 1 million hours and then request to be paid, right? So that's going to be too high, and so you need to validate for that. So if the input is invalid, it's not valid, then you continue. Otherwise, you have to stay in the loop, display some kind of an error message, and get the input again. Okay? So it's pretty straightforward. So the input validation loop, so let's say here, enter a test score, input the score, make sure it is not lower than 0, right? So your scores are usually, no one's going to get a -20 or no one's going to get 150, right? It's usually somewhere between 0 and 100. So you can see here, while score less than 0 or score greater than 100. So think about it, 0, 100. So it's got to be in this range. But if it says while score is less than 0, that means it falls over there. Or score is greater than 100, it falls over there. All right, if that happens, you know, you want to stay in the loop. And you stay until you've got the appropriate value. So you display an error, the score cannot be, you know, outside of the range. And instead, you enter the value again. And that's it. That's the input validation. It's pretty straightforward. The only thing that's, you know, will vary is this, right? That condition. What is the condition that, because it depends on the problem that you have. What is the condition that you're currently evaluating? Does that make sense? Are there any questions so far? No? All right. The input validation loop So usually what you do is you create, we've already talked about modules and functions. And so that's usually what you will do. You will create a function or a module. For this, just to, because if it's too complex, you just want to have these convenient, handy functions. So for complex validation, it is recommended to write a function. This process can make the code look cleaner. And I'm all about code that looks really, really nice and clean. And you should be too. Validating string inputs. Some strings must be validated, such as those programs that ask for a specific string input, like yes or no, right? So you might have a list of accepted words, or something like that. But Python has a lot of built-in functions to say, is this an integer? Does it have an @ sign? Is this lowercase? Is this uppercase? Is this a number? Is this a string? So it's got a lot of those. Or programs that specify a string to be a specific length, like a password validation, right? So we all know we want, your password must have, you will do this a lot, right? So these types of validations, when you start developing websites and your courses, or if you've done so already, validating the inputs, such as validating a password. What's the length? Well, you know how to calculate that because you just take the length. So you should know how to do that. And then you can check, okay, are any of these characters in it? Simplest way is to have a for loop, right? Iterate through all the characters and find them in the string. Okay. You do that for letters and numbers and even special characters. Okay. Defensive programming. So input validation is defensive programming. The input validation is defensive programming, the practice of anticipating both obvious and unobvious errors that can happen. And that's, sometimes this is difficult, right? Sometimes you can anticipate some things, but there are things that you might be like, wow, I never even thought that could happen. And, that's certainly very valid. It's not, humans make mistakes and humans write code. Therefore, code will eventually have mistakes. I mean, that's just nature. It's part of how it is. Types of errors to consider: an empty input, for instance. They just press enter, maybe by accident or something. So you got to validate for that, because you don't want programs that just constantly crash. Users will become irritated by that. Or the user enters the wrong type of data. Like I said, they were supposed to enter 8, but they entered the string 8, not the number. So that could happen. Other common errors to be aware of: state abbreviation should be 2-character strings, for instance, and they just say, IND, right, for Indiana, right? Or zip code should be in the proper format of 5 or 9 digits, right? They could forget the dash, they could, all kinds of things. Hourly wages and salary amount should be numeric values and within ranges, right? As I said, nobody works 1 million hours or earns $1 billion an hour, right? You wish. Dates should be checked, right? So that's a big one. And it's usually not trivial, actually, to check dates. So it's not super, I mean, it takes a bit of work. Time measurement should be checked. Temperature, good example, right? There is no 500 degrees Celsius usually, or 5,000, sorry, or 50,000 for that matter, unless you live on the sun, I think. Check for reasonable numbers, right? Figures, etc., and so on. There was one common mistake that was made by programmers before 2000, right? Well, something called, you guys may have heard about it. It was called Y2K, right? And Y2K, because they were trying to save memory, they created a variable that could only hold 2 digits for the year, right? And the year, you know, is like 78, 84, 98. But what would happen when they got to the year 2000? It would revert back to 00. But would it be 1900, 00? Or 2000, right? And so basically they had to adjust their code to deal with this kind of thing, right? So these are things that you don't always anticipate might turn out to be unreasonable numbers. Are there any questions so far? No? All right. All right, so that's basically it for the input validation. As I said, it's pretty short. It doesn't really have much. What we're going to do now is we're going to take a few minutes and I'm going to ask you guys to implement which one was it? The password. Where was that? Yeah, there it is. So I'm going to ask you guys to implement the some type of a password validation program. So a password validation program would entail, so let me switch back to the Jupyter Notebook. All right, so I'm going to share the Jupyter Notebook here. All right, here we go. So you should be seeing the Jupyter Notebook. So let's take about 10 to 15 minutes. And I want you guys to really try to do this on your own. Open up your own Jupyter Notebooks. You don't have to submit this. It's not a quiz or a homework. It's just, you know, work through this before I solve it, okay? I don't want to just like solve everything. I want you to at least try, and then maybe you guys, after you've tried it for 10 or 15 minutes, you can tell me, you know, how to type it. So I'm just going to sit here and I'm going to let you guys tell me, okay, now type this, type that. All right, so what we're going to do is implement. So, you know, I'm going to create a problem here. And I'm just going to say implement, remember the pound signs are comments, implement a password input validation you know, program. Okay. Use a function. Okay, so for example, a user would type, you know, you'll have a user and you will have a password, right? And so what I want you to do is, you know, you're going to have here, they'll type like, you know, J Smith, you know, at email.com, something like that. And that should be, it should be an email for the user. And then the password should be things that have, you know, like uppercase, and then some letters, and then some numbers, and then some special characters, you know, like that. Do you guys see that? So we got to create a function that will just take this. So initially, you know, I'll give you a little bit of code. As you might imagine, you know, you would probably take, you know, print enter username, right? And then everything else that follows. Then do the input validation. And then over here, print just, you know, what you entered. That's correct. Print user and password. Okay? So we're going to do that. So let's take about, let's say until it's, you know, until like 1, work on this problem for a little while. Or let's just take like 10, 15 minutes. And then maybe ask questions. And then I will solve it. Keep in mind, the input validation chapter is very short, okay? And I'm about to start the files chapter. And so I want to do it at least one problem of this before I move on. But as you can see, this is all we're going to cover of input validation. So let's try to think a little bit about it, okay? So let's take about, you know, like I said, 10 to 15 minutes, work through this, okay? Are there any questions? No? Okay, so open up your Jupyter Notebook. Open up your Jupyter Notebook, please, and just start solving this, okay? Implement, you know, so login, so somebody types a user and password, validate for it, okay? Using a function. Okay, think about how you would do it. All right, and I'll give you 10 to 15 minutes. And then just ask any questions if you have them. I'm also going to pause the video given that, you know, I won't be talking, so there's not a long pause there. Okay, so you've had a few minutes to think about this problem. Okay, so now you should have some ideas on how to get started. Okay, so remember, we are going to create this input validation. So what would you do? What's the first thing? What would you suggest?
The first thing I did was print enter username.
Okay.
Then I put what we already got, user enter password. And then right now, kind of caught up to where I was already at.
Yeah, so
I was wondering if wouldn't they count it as a string? So would I even be able to put the password as a function? I was going to just do like if, because I already established like password equals the string. But if I put if password equal, or can I even say greater than or equal to? I was confused. I was like,
all right, so you can do, for instance, user equal input, right? So you get the input of the user, then you say print password, enter password, right? So that, you know, that's sort of the idea. Pass input. So the question is then, can you continue on to the next one, right? Or do you do this? So what you could do is you could have a function that says, this is a, you know, kind of a standard approach, is user. So it's just a little function you're creating, and it's basically saying, is this a valid user? So the input to it would be user, right? So that's what you type in. And this function then you will have to define. So you say, if is user, right? Then you continue basically. Or rather, if not is user, then you want to stay within the logic. So maybe not if, but while, right? So while, so you stay in a loop. And you say while not is user, you're going to continue asking for the input. So you can just copy this in here, right? And you keep doing that until you find a valid user. You see that? Obviously, we need to define what this function will be. So we need to define that. Okay, so you're going to say, you know, define is user. Remember, that would be a different variable. And then here, we need to, you know, figure this out, right? So for now, I'm just going to put in like question marks there. But that's the approach to take. And so now I can take the other one. So once I'm done with user, then I can proceed to password, right? And I can say pretty much the same thing. I'm just going to copy this, go over here, and I'm going to say while not is, but now you have to change this to password. While not is password, and then password here. Make sure you, oh, let me change this to password because it was highlighting it green, so it was not liking that. All right, so while not is password, you do the same thing. Enter password, right? And this is going to be password. You guys see that? That's the main logic. And then by doing this, now you have simplified the code quite a bit. So now you can just go into those functions and define what you want. So let's just say at the end, if you've made it out of these two, then you can just print out print user and print password. Right, so you made it to the end. So you print them out. But if you don't, you stay within these loops. So that means we need to have two functions here. We need to have two functions here. Is password is the other one, right? And then again, we just have to figure out what this logic will be. But it's like I separated the problem into two things, and one part of this is already solved. Does this make sense, guys?
Yeah.
Okay, great. Let me know if you have any questions. All right, so I have my two functions there, and then I have this code here. I'm going to get rid of this comment because I already did it. All right, so then now we can start defining what we want in the user, right? So the user should be an email, correct? User should be an email. So we can do several things. So these two functions are very convenient because all they do is they return a Boolean, right? So let's say passed or something like that. So is user, right? Passed. So initially it's going to be false, so it doesn't pass. But we need to return passed, whatever it is. So we need to change passed to true if it's a valid password, or valid user, sorry. So here, a user can have numbers, can have strings, but for it to be an email, what character does it need to have for sure? Nobody? You guys don't know how emails work? Another way, I'm going to change the logic here actually to true from false. And you'll see why. In this one, it's actually easier. It's almost like it's easier to prove one thing versus the other, right? So in this case, an email, you know, I've seen email addresses that could have numbers in the, I think I've seen them at least, in this part, in the domain part. And I can't think of one right now, but I'm pretty sure. And this could be .edu, .com, .ai, so many things, gov. So really, I'm just gonna, and this could be numbers, strings. I mean, you can literally write whatever here. So basically, I'm just gonna validate for the @ sign and the dot, right? Because all emails have that. So basically, any email will work, any input will work as an email as long as it has the @ sign and the period. So what do? So if @ sign, oops, that's not the @ sign. If @ sign not in user, then what do you think I should do? Past equal what? False, right?
False.
Exactly. And then we do the same over here. If period not in user, same thing. So it's almost like it's true most of the time, except if it fails these things. So we're going to say past equal false. Now you can have a more restricted email policy, like in your government, you know, in your company. And so right? So so that's basically like I did. So go ahead and try this and see if it works. All right, so that's for user. Now let's try password. So for password, it has to have, the first one needs to be uppercase, has to have characters, numbers, and the @ sign and special characters. So that's a little bit harder to do, okay? So let's think about it, but it's gonna be the same logic. For the @ sign, what I can do is, and I'm gonna have to do past equal true, return past. So for the uppercase, what we can do is I can take, let's say, first character, let's say. First character, and it's going to be, oh, and I need to have password in here. Password. And it's going to be the first one, right? So if I grab 0, and I'm also going to make it, so in Python, there should be upper. Although it's not recognizing that as green. So there's a function in Python called upper. Okay, so it's actually not like that. It'll be like this, to upper. It'll be dot upper. I think that'll work. All right, so that will just take the first letter and make it uppercase. Or actually, no, that's not how it should work. No, that could be how it works, I guess. Oh, is upper. Hold on. It's even better. So I'm going to do if. So it should be Python is upper. Yeah, so if password 0 dot is upper, okay, so this will check and it'll return true or false based on that. So if, but actually what I want to say, if not password is upper, right? So if it's not upper, then I'm going to say pass equal false because it's not upper. All right, so let's just do that one. At least now we have one to test. Okay, so let's go ahead and run it. Okay, so I'm going to enter a username that's got to be an email, right? So I'm going to enter just, string. Okay, doesn't like it, see? Doesn't like it. All right, now I'm going to enter one, Mary at email.com. Let's see what it says. Okay, see, it liked that one. So it validated for that one. Then I'm going to do the password. So the password, I type some string, doesn't like it, doesn't like it, doesn't like it. Here, the first letter needs to be capitalized and it'll pass. So let's say Mary, uppercase, and it liked it. See, and so now user and password is printed out and you can see Mary at email.com and Mary the password. Make sense, guys?
Yeah, it does.
Yeah, it really does.
All right, so that's pretty much the example. And from there, as you might imagine, you could continue. You can also do, check for, you can have a list of characters that are accepted, exclamation. So that should be pretty easy. It's just, for loop, you have like a list of accepted, characters, right? And so you have a list and you just say like, okay. So accepted is like exclamation and what was it? @ sign. Needs to be double quotes. All right, and so now you have this, and so you would just kind of iterate through this. You would do you have to take all the characters in the string and check that at least one of them is in this list. All right, but that's pretty much, I leave that part to you, kind of play with. And that's it. That's input validation for us. Okay. All right. So I'm gonna wait a couple of seconds to see if there are any questions, and if there are no questions, we're gonna move on to the next topic. Okay. Remember, this is a short one. All right, so let's go ahead. Since I don't see any questions, I'm going to move on to the slides then. We're going to go back to the slides here. But a new set of slides because we are done with the input validation. All right, so I'm going to throw that away. And now let's just take a look at files. So I'm going to, files, I'm not going to rush this topic. Well, it's a very useful topic. And Python has a lot of ways of doing this. You'll probably find it funny, but we're not going to learn this right away, but there's a module called the pickle module. So just like, like the thing that you eat pickles. And it's a really great thing because it allows you to store any type of data structure into a text file directly. So it makes it very easy so that you don't always have to like, oh, how do I take this and reformat it and save it to a text file? You just literally take the data structure and you dump it into what is called a pickle file. And so that's very handy sometimes. And you will actually use it in 350, for instance, when you take cryptography and you don't want to deal with, hexadecimal values and things like that. But for now, our focus will be more on the text side of things, which, when you take 372, which is the Linux class, you will see pretty much everything is a file in Linux. And so knowing how to manipulate files via Python, for instance, is actually very, very useful. But you will use it for many other applications as well. So you should be seeing my slides, okay? Should be seeing my slides. Now, as you can see in here, as you can see here in my slides,
I see Python still, or Jupyter Notebook.
Yeah, so do I.
yeah, I forgot to share it. All right, now I have shared it, I think. All right, so as I was saying, these are the Python slides. As you can see, there's two topics here, files and exceptions. This one called exceptions is what we just talked about, input validation. Okay, so just be aware of that. In the new book, it's called exceptions. What is this? You'll see it's the same thing. All right, but really, so we've addressed, so I'll cover this from the Python perspective. And then really, the new topic is now files. And what that means basically with files is, currently we store our data in a list or a variable, right? That's where we store our data. So we have a list of values, 2, 3, or we have, not that. Or we have, hello. Right, so that's sort of how we store, but we store everything in memory, which means we store everything in RAM memory. However, as you know, RAM memory is dynamic and volatile, and when you turn off the computer, it goes away. So what if you want to save that data on, you need to turn off your computer, but you want to save that data to a file as a permanent thing, right? And so in that case, you need to store your data in an outside, not RAM place, right? And so you're going to store it in the what is called the hard drive or the SSD, right? But so what is called, it used to be called the hard drive. Now because of SSDs, I think they just call it the external drive or the drive. So whatever the name, storage, drive, we're going to store it in a separate thing, a permanent drive, okay? And that's really the idea. All right. So we need to find a way to do that. So that means we need to create a file. You know, usually for this, the files could be two types mainly. Text files, which basically they just look like strings, like ASCII characters, or binary files like a pickle file, etc., which is basically, you know, like gibberish. It's converted into some encoding and you can't really make it out, but usually those are, like I said, the good example of that is like taking a data structure, a dictionary, you know, that kind of thing, and just efficiently dumping it into a file, sort of a binary file. Like in Python, you have the pickle module that helps you to do that. All right, so the topics then for this one are the introduction of file input and output, using loops. Again, you can see that loops are the workhorse of programming, right? We're going to use them again to process files here. You know, reading and writing, usually it's an iterative, sequential kind of thing. We're going to process records. So what that means is you have a file and every row is a record or some string that you want to read, a comma-separated file, etc. And then there's exceptions, you know, which ties into input validation, but also handling little errors in reading. So at some point, we're going to learn something called a try-catch. And you'll see this is a very powerful thing, or, you know, try exception, whatever it's called. And that's another structure that does error handling, and it does it really well. Okay? So basically the idea is that your program will not error out anymore. So it's not going to error out, and that's really great. All right. Okay, so now, so introduction to file input and output. For a program to retain data between the time, this is the formal definition, as you might imagine. So for a program to retain data between the time it is run and the time is run again, I guess is what they mean, you must save the data. Data is saved to a file. And that's always the terminology in every give me a sec, guys. All right, so data is saved to a file, typically on, as I said, on the computer disk, right? Or, you know, it could be a flash drive, etc. So saved data can be retrieved and used at a later time. Writing data to, which is saving data on a file. And then the output file is a file that data is written to, right? So so this is just the terminology. So output file is where you save it. And it's something, actually the output file is something that you can take with you. You can save it to a text file. You can attach that text file to an email, for instance, email it to yourself. So, or one thing I would recommend that you guys use is GitHub. I think I've mentioned that before. You know, you can load your data to GitHub and just have it there kind of in, you know, in cyberspace or the internet or whatever. And that should be helpful to you. So writing data to a file, as you know, you have, you know, I'm not really going to get into that, into the details of the operating system. This is how the operating system should work. You guys have an operating systems class that can describe that in a lot of detail. But basically the gist of it is, for our concerns, is that you have data and it's going to be copied from RAM to a file. Something like the variable pay rate, employee ID, and employee name. Okay, so these parameters are going to be stored in a text file in some specific format. Okay, this is just, you know, this is kind of a, I don't know, an analogy or how it works on the computer, but really we need to store it in another way, right? We need to find a way to store it conveniently in our file. So these are just, again, definitions: reading data from, process of retrieving data from a file, and then the input file, a file from which data is read. Okay, there's 3 steps when a program uses a file. First, you have to, and this is true, open the file, then you process the contents of the file, and then you close the file. Make sure you always close the file. This is one thing that we all forget to do. We always open the file, we always process it, and then we forget to close it. And if you don't close it, sometimes you can have problems, right? That's the problem with that. You know, it might work like 98% of the time, but 2% of the time, it's not, you know, that this can cause problems. Okay. All right, so that's just the same. I'm not going to talk about that. All right, types of files and file access methods. So in general, there are 2 types of files, and I think I said that. There's text files, and then there's binary files. So text file contains data that has been encoded as text. Okay, just basically a string. We are going to focus our time on this one. Binary file contains data that has not been converted to text. So this, you know, I think, you know, the pickle module in Python is an example of that. 2 ways to access data stored in a file: basically sequential access or direct access. So in direct access, you can jump directly to any piece of data in the file, right? But you have to have some kind of an index. So we're not really going to cover that. Instead, we're just going to mainly focus on sequential access. It's file read sequentially from beginning to end, and you can't skip ahead or skip something. You kind of have to go sequentially, all right? So basically, our focus will be on this one and on that one. And that's mainly what you will use. As I said, when you do like pickle dump, you might do this in the future. File names and file objects. File name extensions. There's short sequences of characters that appear at the end of a file name preceded by a period. So extension indicates type of data stored in the file. Usually, I just like to do .txt or .csv, right? CSV just indicates comma separated file, and that just indicates that every value in a row is separated by a comma. Or sometimes I just do txt, and then I know, okay, I just mean a text file. Others use .dat. I'm not big on that. Doesn't mean anything. So, but I think in the book they have that in there. Now, for you to reference a file in a program, you have to create an object. You will see that it's pretty straightforward. You just create a variable basically in the program, and the variable becomes a reference to that file. It's an object associated with a specific file, provides a way for a program to work with the file. Okay, so it provides a way for a program to work with a file. The file object referenced by a variable, as I said. Okay, and then they keep showing this graph. Whatever. All right, so opening a file. So here now we're getting into the syntax of Python. I'm not going to do any examples today. I'll leave those for the lab on Thursday. So today we're just going to finish this up. But files are pretty simple. They're not really that complex. I think they're actually a lot of fun to play with. So we'll certainly do that. You use them, as I said, we'll use them quite a bit in 372 for, which is our the Linux class. You know, you have to read files like log files, for instance. As you know, the computers log, and also you have a class 265, which is, you know, your AI class, artificial intelligence. So that class, which is, you know, like data science things, you have a lot of data sets as well. And the data sets sometimes have to come from text files. So you'll learn about those later. All right, so then let's go ahead and talk about opening a file. So open function. It's used to open a file. It creates a file object and associates it with a file on the disk. The general format is going to be like this. You know, that's the variable name. Usually I use, and because, or I shouldn't say I use, you know, the Python style maybe is, I think, to use the word F, or sorry, the letter F. So what I usually do, so usually when you write a program, you have like an input file and an output file. That's a very common thing. So then I will probably say F input, and then for the output, I'll say F output. But you'll see a lot of the time, if there's only one file, a lot of people just do F. I would not do file. I just, you know, I wouldn't do that. Sometimes though, you might just do F and you do whatever it is. So let's say that you're reading, you know, student names. So F students, for instance. Again, that's the variable name. It can be whatever you want it to be, but usually it makes sense to put that F underscore in front just to kind of indicate what it is. These are just conventions in your programming style, but they're conventions that are good to have, right? You know, it's like that comfortable feeling that you get of knowing, you know, like a warm blanket, right? You just feel comfortable. Oh, you know, when you do these things, and so I would recommend you do that. And you can see that it's even there. I mean, I just don't like using the word file. All right, then the keyword for sure, whenever you're doing a file, it's going to be open, okay? That's going to be the keyword that you use. Then the file name, this is going to be the name of the file in your disk, all right? And that may need to include the path name as well. So for instance, if you have the file on the desktop, or you have the file in your My Documents, you know, you need to have that. So that's going to include the path and the name. So for instance, it could be user home, you know, J Smith desktop. And then plus, so I'm going to concatenate two strings, you know, file one. Okay. And so that's going to be and file1.txt maybe. Okay, so this file name that I'm talking about is really the name on disk with the extension, okay? So just be aware of that. And then, because you have to tell it, I guess this is where going back to this figure makes sense, that the object is pointing to the location in your file system. All right, and then finally, the other one is mode, which is this one. And the mode of operation just indicates what you're going to do with that file. So it's a string specifying how the file will be opened. For example, is it a read-only file? So it's a data that you only need to read. So then you use an R. Are you writing? If you're writing, you use a W. Are you appending? Then you use an A. So writing is important to differentiate writing from append, because when you're writing, even though you may already have data on that file, if you use W when you open a file, you're going to rewrite the contents of that file. So you're going to lose everything. However, if instead of W you use A for append, you're not going to overwrite things. Instead, you're just going to start adding at the end, right? So this is good for, let's say that you want to log things. You know, you're logging everything that's happening in the system. And so if you're doing that, you are, you know, you want to use appending or the A. If you're gonna just write from scratch, you know, you use W. If the file doesn't exist and you open it with W, it'll just create it for you. So that's kind of the convenience of it. However, for reading the R, it's not going to create it for you because that makes no sense. You know, it's expecting to read something, so there's got to be some data in there. Okay? Does this make sense, guys? Are there any questions? All right, so let's do an example. All right, so let's say, I'm just going to say F in open, and then my file is called students.txt, right? So I'm going to say students. Now, if I just do this, it can only look for this file in the current working directory. Remember that whenever you're running a program, let's say that you're on the desktop and you're running it from the desktop, it will only find that file on the desktop. However, if you have that file somewhere else, you have to specify the path, okay? Which is, you know, kind of like that. And then I want to just read the file, so then I'm just going to say read. Like that. You see that? By default, if you don't do anything, like if you just did this, by default, the default value is only read. Now, if you want to, as I said, if you want to write, then you do a W. And then if you were just going to add things like in a log, you would do append. Okay? Right. All right, so now, as we continue here, specifying the location of a file. If the open function receives a file name that does not, which is what I just said, that does not contain a path, it assumes the file is in the same directory as the program. This is called the current working directory. Right? So it means the file is in the current working directory. If program is running and file is created, it is also created in the same directory as the program or the current working directory. You can also specify an alternative path and file name in the open function, and that will just find, you know, so you can find it when it's not in the current working directory. Okay. All right. Writing data to, oh, okay. So once you've opened the file, the next things you want to do are you want to read and write. So as you might imagine. So then we have some built-in functions. The object F, for instance, F in that we had before for the object now has built-in methods associated with it through a period, right? And in that case, we can say, oh, I want to read. So read lines, right? And it'll read the contents of the entire file. This is a function that basically returns a list. So whenever you make a reference to fin read lines, that function reads something and it puts it in a list. So it really becomes like you just have a list of the contents of the file. It's quite convenient. We'll see that in an example later on, but this is convenient. Now, here's another thing that I should say. For everything that we're doing, the files are going to be pretty small, so it's not an issue. But as you start to do more real-world problems, you're going to find that your files are very big, right? That you're doing things. So when that happens, guys, you have to be mindful of how you write your code efficiently so that it's not too slow, okay? Don't worry about it for this class, but just be aware that at some point, you will have to adapt your code to be able to read and write, you know, to be able to figure out how to read and write things, okay? So anyway, that's sort of the idea. So now let's think about it. So writing data to a file. A method, as we know, is a function that belongs to an object. You know, in this case, the object is fin, which is the reference to the file on disk or the drive. It performs operations using that object. So the file object, fin, has methods like write. So you can see it just like read lines, fin has write. It's a write function associated with it, or called a method. So the file object's write method used to write data to the file is as follows. You have, you know, the object, the function write, and then of course you have to specify the thing that you're writing to the file. And then once you're done, you close, the file should be closed using the close method. You can see that there. Are there any questions so far? No questions? Everything making sense? Okay. All right, so the other side of the coin is reading, right? So in the previous one we wrote, and in this one we're going to read. So reading data from a file, the read method. The file object method that reads entire file contents into memory. It only works if file has been opened for reading. And the contents are returned to the program, to memory, to RAM as a string. See that there. There's also the read line method, or read lines, the file object method that reads a line from the text file. The line returned as a string, including the new line character, right? The new line character is something that tells the program to move to the next line, or to print, you know, like an enter and move to the next line. We'll see how that works. Don't worry about it right now. This can only make sense as we start writing the code. All right, and that usually the object handles the read position, which marks the location of the next item to be read from a file. All right, so I think this is a good, it's starting to get a little, you know, with all this, a little more complex. So we'll pick this up on Thursday. I think this is a good stopping point. So I'm gonna give a couple of minutes here for those of you that may have questions. Otherwise, we are gonna stop here for today, and I will see you guys on Thursday.